So far, we have looked at the greatest common factor. Then we looked at how to factor the difference of two squares. In this lesson, we will look at trinomials and a particular type of trinomial with a leading coefficient of 1. But before we get there, let's go back and review multiplying binomials. Remember that FOIL method? Because if we have a binomial times a binomial, let's see what happens. If I multiply first, outer, inner, last, and then we collect like terms, remember those middle terms, we get a trinomial, and that leading coefficient, the coefficient of x squared, in descending order, the largest term, that coefficient is 1. What happens here? X squared minus 6x minus 5x plus 30, and again those middle terms, gives us a trinomial with a leading coefficient of 1. Let's do one more. Middle term, and we get a trinomial of 1. Today we have to say, where did that trinomial come from? It came from those two binomials. That's why it's important to look at this, because we have to now go backwards. This 6 came from multiplying 2 and 3. The 5 came from adding the 2 and 3 coefficient of x. Did that happen here as well? The 30 came from multiplying negative 5 times negative 6, and the negative 11 came from adding the negative 6 and the negative 5. Here the negative 14 came from multiplying the negative 7 and positive 2. The negative 5 came from adding those middle terms. We're going to use that knowledge to go backwards. So how do we factor a trinomial as long as it has a leading coefficient of 1? Well, we ask ourselves, what two numbers multiply to get the constant c, which is that last term, and add to get the middle term b? And yes, we have to take signs into account as well. So we have a leading coefficient of 1. So we know x times x is x squared. Now what two numbers multiply to get 20 but add to get 9? 5 times 4, doesn't matter where you put it, and they both have to be positive, because 5 times 4, if I multiply that together, I get 20, and if I add 5 plus 4, I get 9. You could check it by multiplying out your answer and getting back to where we started from. Let's look at number 2. We have a leading coefficient of 1, so I need x times x to get us that x squared. Now I say, what two numbers multiply to get positive 21 but add to get a negative 10? Well, the only way you're going to add to get something negative, yet multiply to get positive, is if they're both negative, and 3 times 7 should do it. Negative 3 times negative 7 is positive 21, and negative 3 plus a negative 7 is negative 10. Again, knowing your multiplication tables is very important. Number 3, we have a leading coefficient of 1, so we need x times x, which is x squared. Now there's a negative 1 in front of that x. So again, what two numbers multiply to get negative 2, but add to get negative 1? Well, the only way you multiply to get something negative, if one is positive and one is negative. The only thing that multiplies to get 2 is 2 and 1. So the question is do we need negative 1 and a positive 2, or do we need a positive 1 and a negative 2? Now when you multiply them together, you get negative 2. But what about adding? Which way we would have to add them to get a negative 1? It would have to be this one, right? Because when we add, we take the sign of the larger one. So we need a negative 2 and a positive 1. Double check, multiply it back out, see if you get what you started out with. Number 4, we have the leading coefficient of 1, so I need x times x. Again, what multiplies to get negative 9, but adds to get negative 8? Well, 3 times 3, that'll get you 9, but it won't get you 8. So what else multiplies to get 9? That's right, 9 and 1. But one needs to be negative, one needs to be positive. If I need to add to make it negative, the larger one needs to be negative, the smaller one needs to be positive. So I need a minus 9 and a plus 1. And again, you could have written it as x plus 1 and then x minus 9. The order does not matter because we are multiplying. So look, the first one, we had both pluses. The second one, we had a plus here and a minus there, so we had to have a negative times a negative to get that positive. We were multiplying. But when they're both negative, you're going to plus and a minus. And you have to work them out right where you get that middle term. Let's look at number 5. Well, we have a leading term of 1, so I know x times x, and I need a negative 1 in the middle. Now what multiplies to get 10, but adds to get a negative 1? Well, let's see, 5 times 2 is 10. 1 times 10 is 10. Is there any way we could add or subtract these to get a negative 1? Well, 5 minus 2 is 3. 2 minus 5 is negative 3, so that doesn't work. 10 minus 1 is 9. 1 minus 10 is negative 9. That doesn't work. So have I messed up? No. This is prime. We cannot factor it any further. Now we're going to combine that greatest common factor in trinomials. So we started out easy. You always want to look for a GCF. So look at the numbers. Those are all 3 divisible by 3. They don't have any letters in common. So if I divide all of them by 3, I have this. Am I done? No, because now I have a trinomial that has a leading coefficient of 1. So on the next line of notebook paper, again that two-step process, I say x times x is x squared. What multiplies to get positive 6 adds to get negative 5. Well, we could have 2 times 3 is 6. If I make them both negative, negative times negative is positive 6, and if I add negative 2 and negative 3, I get negative 5. But wait. What if I had put positive 6 and a negative 1? Well, if I add that, I do get 5. And if I change the signs and make that one negative and that positive, I get a negative 5. Can I use that? No, because if I multiplied that together, I would get a negative 6, and I needed a positive 6. So check your signs. Lots of stuff to check. Number 7, do you see a greatest common factor? Well, all the numbers are even, so I know a 2. Oops, I got a little bit carried away. Let's see, I'm going to put the 2. What else do I have? Oh, I see an x and a y. So I'm going to divide all of these by 2xy. So let's see, that leaves me x squared plus 7x minus 18. That's one step. Can I go further? Well, it's a trinomial with a leading coefficient of 1. Is there something that multiplies to get negative 18 but adds to get a positive 7? Are you thinking about that? Well, how about 9 times 2? And I'd have to have the 9 positive and the 2 negative to add to get a positive 7, and I have to have a plus and a minus to get a negative 18. Again, there's that two-step process, two different lines of notebook paper. If you just put down an answer, I'm counting it wrong. Now number 8, it looks pretty easy, but what's different? It's that negative in front. We could keep that, but it's a lot easier if you factor out a negative 1. They don't have anything in common, but you have a negative. So if I take out a negative, meaning I divide everything by negative 1, that's going to change all the signs. And in this case, they're all going to change to positive. Can I keep going? And now on the next line, I'm going to write that just as a negative sign. So what multiplies to get positive 8 and adds to get positive 6? Plus 2 and a plus 4. But I still had to have that negative, so when I multiply all of that out, I would get back where I started out with that had a bunch of negatives. I'm going to do the same thing on number 9. There's not really any other common factors except for that negative 1. So I'm going to factor out a negative 1 first, and that changes all the signs. If you divide everything by negative 1, it changes all the signs. Then I see a trinomial with the leading coefficient of positive 1. Is there something that multiplies to get positive 12 but adds to get a negative 7? So if I multiply to get positive and add to get negative, I know I need a negative times a negative. And how about 3 times 4? Does that get me positive 12? Does it get me negative 7? Yes, it does. So again, a two-step process. Factoring out the negative 1, changing all the signs, and then keep going. Now 10 and 11 look a little bit different because they have x and y, but don't panic. Same thing. There's no GCF, there's a 1. So again, we have x times x. Let's just look at those numbers. Is there something that multiplies to get negative 18 but adds to get a negative 7? So if I multiply to get negative, I have to have a negative and a positive. And if I add them and I want a negative, then the bigger number needs to be negative. So 9 and 2. Now if I just left that as the answer, it would be wrong because I don't get this y. How am I going to get that y? Well, what if I put that? Let's just check that out. Let's just multiply those out together. Let's do that FOIL. So x times x is x squared. And when I multiply that, I'm going to get 2xy. Multiply that out. That's minus 9xy. And then I get negative 18y squared. If I put that together, I'm back to where I started out from. So don't panic if you see that xy in the middle. It's just going to separate the x's and the y's in the parentheses. Number 11. We not just have a negative in front, we have a negative 3. Well, could that be the GCF? Does 3 divide into all of those numbers? Yes, it does. Do they have any letters in common? No, they don't. So if I divide everything by negative 3, that's going to give me positive x squared minus 4xy minus 12y squared. So here we have that x and y thing. I have a trinomial with the leading coefficient of 1, so x times x. So is there something that multiplies to get negative 12 but adds to get negative 4? 12. 1 times 12, 2 times 6, 3 times 4. Well, and one needs to be negative, one needs to be positive. How about 6 and 2? Does that work? And does the 6 need to be negative? Yes, it does. What else do I need? Look at problem number 10. What do I need to put? That's right, that y right there. Not that hard. So again, I want to go back to here because that gets very important. When you have a trinomial with the leading coefficient of 1, you want to say what two numbers multiply to get your constant, but add to get the middle term.